All right, are we live? Hello, hello, and welcome. Howdy. So we're back. Another problem. We're going to be working on another Leetcode medium, and I just want to give it a moment before I get going. Yeah. So interesting day today. Interesting kind of sequence of events, I guess. Just praise God, another day to live, and yeah, thank God. You know, not much to say other than thank God, right? I have such evil, bitter, resentful, wicked thoughts constantly, and they're horrible. They're terrible. I won't have them forever, I think, and I don't know. It's like I do know what it is. I'm evil. That's it. It's really simple. It's just I'm really evil. I need Jesus. I need to stop acting on my lusts, call it, and I'll be great. I won't just be fine. I'll be fantastic. I mean, the gifts, the blessings that God has given me are way beyond anything I deserve, and they're really good. And I don't know, it makes me almost want to cry because it's just, I'm so evil and undeserving, and I know that I'm going to be okay. I just refuse to believe it sometimes. Refuse to just kind of let it be. Just let it, you know, just be a righteous man. Be fine. Given a string s and an integer k, you can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. Given a string s and an integer k, you can choose any character of the string and change it to any other uppercase English character. Okay, uppercase. I guess all of these are going to be uppercase. Only uppercase, okay. Any other character. Perform this k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. So k is 2, we can replace b with a and a, or a and a with b and b. Place the two a's with two b's, or vice versa. Look at 4. Oh, that's interesting. So we kind of want to connect the sequences, right? That's sort of the ideal approach. Oh, this is a really interesting question. Whoa, it's new to me. There we go. And then we have A, B, B, A. I think I have to do a few like test problems. I guess you could do 4 if you replace this with an A. You could do 4 if you replace this with a B. I think that's the best you can do. The one A in the middle with a B has the longest repeating letters, which is 4. And we have 100,000. Okay, this consists of only uppercase English letters. All right, let's see how we do. Let's try some test cases here. It could be like a lot of different, like A, B, C, D, E, and F. F, E, D, C, B, A, right? So it could be a few different things. And A, B, C, D, E, F, F, E, D, C, B, A. So, I don't know, if K was 2, we could replace these two E's with F's, and that would give you 4. Just call it F as 4. Or maybe we should do R. Result. Obviously that's by inspection. We could do the DE, could be F's as well. So if there are no connecting portions, I guess no consecutive sequences, then your best bet is to find the largest one. Well, no, it could be, that's not necessarily true, but let's say I'm not sure what the conditions would be, but there are some conditions that I can't quite describe at the moment, articulate, where you would just find the largest consecutive sequence and effectively add k to it, right? So there's some cases where that's the case, where that's true. Like this is a case. However, really you want to connect as many sequences together as you can, right? So there's sort of a greedy algorithm here too. But if you can't connect these sequences, well, there's only 26 characters, so you actually, it's not that hard to figure out, like, let's suppose you pick you pick one of these characters, right? And you say, okay, let me try to find the longest string I can make of just this character, right? So like A is clearly 3, right? Because you can only do AAA here and then AA here, AAA here, and you can't connect these at all. And you can do the same thing for all 26 of these, and then just take the longest of those 26. So it's kind of an easy question for that reason, because really you could just consider one character at a time, right? It's still constant, still linear time. That's just a constant multiple of how many times you have to operate here. So maybe this is a little bit easier than we thought. It seems kind of hard because it just seems like, you know, a lot of different characters, but it's only 26, so it's the character. So you just multiply by the character set, I guess. So then the question is, okay, like, how do we? You can kind of rephrase this as to like just some character in a slot and then empty slots between these characters, and some of them are consecutive and some of them are not. And how would you place characters in the slots to get the longest sequence? How can you do that in linear time? I think we can, but I don't know. And also this has to be linear time because the inputs are quite large, 100,000. You won't get, and how are we doing on time? 7 minutes? It has to be linear because the inputs are quite large. Let's see, where is, yeah, it has to be linear because the inputs are quite large. So all the other possibilities would time out. Maybe n log n, but I don't think there's going to be a logarithmic factor here. I don't think so. So we could maybe do a like a sliding window type of solution where since it's going to be the longest consecutive sequence, I think you're going to be in a situation where you can slide left to right, like basically all of the A's that you're going to use should end up in the same consecutive sequence. Hopefully that makes sense. So that's kind of a what's the word for that? Like a, not a lemma, yeah, like a lemma. So that in the final maximal length consecutive sequence, the characters that you place all will end up in that sequence. I think necessarily, if you place all of them. And there are situations where you wouldn't place all of them, right? So if all the characters are just A all the way across, then obviously you wouldn't place any characters because you can't. There's no characters to replace. So actually those sequences would be, so you just have to bound your result by the size of the string. I think that's kind of a trivial thing, minor thing. That could trip you up. Excuse me. So anyway, yeah. So we can reasonably assume that they'll all be in the same consecutive sequence, because that's how you know. Because if not, then you could contradict, right, the maximal property by saying, well, if you had some other sequence that was maximal where one of the characters you had available wasn't consecutive, you could move it to be consecutive with this maximal result, and then it would be larger, and then it wouldn't have been maximal. So you can prove that pretty easily, that they have to be in the same consecutive sequence. The issue then is, and so it's the same character, so they can be permuted any way you want as well. So really you could just kind of slide them left to right. So in that case, I want to say that then since there's only a linear number of positions where you could start placing characters, and then obviously you would place your characters and sort of skip the ones that are A's. And actually, if you can get that result in constant time, that's linear time, right? To get because you can get the largest sequence from each position, starting from each position, and then take the maximum over all of those. The tricky thing about that, though, would be you would need to know I think you could do some kind of pointer manipulation, and I'm wondering if you actually need to modify any characters, though. Yeah, I think you can do some pointer manipulation. Basically, you have a pointer to the, or not pointer manipulation, but like indices. Keep track of like a sliding window. So you would say, okay, the character is A that we're looking for. We're going to start A in this index, and then we're going to scroll the end of our window over, and each time we see something that's not an A, we're going to decrement. And each time you see something that is an A, you don't decrement. But as you scroll, you can take the difference between those two values, and you don't scroll anymore if you hit the end of the string, or if this is the last character in the string, you don't scroll anymore, and it's going to be inclusive, right? So, and if you've actually, no, it's not going to be, it'll be exclusive, so it'll be one past the, so it'll be exclusive, so it'll be one past the sort of what you're including. So if you don't have any more, so if you don't have any more characters to replace, then you would stop if it's not an A, or if you hit the end of the string, then you would stop, right? And if you went past the string, and then you're going to take the difference between those two, and that'll give you the characters that in between. Normally you do sort of like B minus A plus 1 to get the interval, but because this is an open interval on the right side, we don't need to do that, so we can just subtract. So we'll have sort of indices I and J, and what we can do, so that'll be sort of the algorithm to determine J, and then what's going to happen is we're going to shift I and say if this was if I was something that we replaced, so whether or not, you can just check whether or not it's a character, that one of the characters that you're looking, it's not, whether or not it's A, the character that we're looking for. Check if it's A. If it's not A, that means that we have to increment our counter again, and as we shift, and then we're going to shift J down further, the same algorithm. So we have a shift J and a shift I, and sort of subroutines, and then each time you're going to take the maximum difference between J and I. You're going to take the difference in J and I and compare that to a running maximum, and that's it. That actually naturally will handle that edge case where you don't go over the size of the string. And you do that for each character, and then that should be it. That should be a sufficient solution. So that'd be linear. So that took us 15 minutes just to describe it. So it'll take us another 15 minutes to code it. Hopefully we can code it relatively quickly. We'll see how this goes. Alrighty. So we have an outer, we have a loop, so we have int ret equals 0. 26. Character C equals target. It's going to be A plus I. You can actually do it this way. Start off with A to Z, and these are actually capital. So this is kind of a nifty way to do it. And then now we have our target, and now we're going to say int I equals 0, j equals 0 for, really it's a while loop, I think. Could be, I mean, yeah, we'll just do while. I is less than s dot size, say, and we have total or current, or just say current max. So a sliding window on each character, on each target character. And we're going to say, so shift down J, and that's going to be, it's a while loop, right? We said this, yeah, shift down J, so it's going to be while, or just, yeah, we'll do, okay, so you have, yeah, so our count equals K. Two conditions. So we'll just do while true. We say if, for now, we amend our condition. So if J is, so that's actually the exit condition, but that's fine. So if J is less than s dot size, or yes, less than s dot size. Right, so it's greater than or equal to the size. That means we're off the edge. But if we're less than the size, then we're okay. Now we're going to say if s of j is, if this is equal to the target, then we don't do anything. No op. We're going to kind of pretty this up, I guess. But if it's not equal to the target, then we decrement the count. And in both cases, we increment k, or j. And that's kind of it. It's pretty simple, I think. So we just say while count and j is less than s dot size, pretty much. And in both cases, we'll say if s of j is not equal to the target, then we decrement the count. Right. That's j. So j is going to use bits of the count. And we're going to say if current max is less than diff, which is j minus I, and set current max equal to that diff. Okay, and then shift down I, and we'll say if s of I is equal to, if s of I is equal to the target, that means we can increment our count. No, it's not equal to the target. That means we have to, that means we used something to cover that spot. And we're going to unuse it, so we can increment the count, and we're going to increment I here as well. So we have this sort of sliding window approach here, and then we say if ret is less than current max, and set ret equal to current max. We do this for every character, and then return ret. All right, let's see how this goes. See how it compiles. See if we don't get into any trouble here. Where are we? 20 minutes? Okay, not great, but might TLE. I don't know. Okay, it's correct on this case. How about the other test case, which is A, B, A, and 1. How about that one? Should try a bunch of, oh, I was wrong. Oh, expected 4, got 3. No, really? Oh no. No kidding. What happened? Count is 0. We don't move J. Oh, actually, that's wrong. That's why. Okay, got it. Got it. Yeah, so that's actually part of the issue. So you have to say, I see. Okay, okay, it's a very subtle thing, but the way that I programmed this, we would say if S of J is not equal to target, you have two things. So if count is less than or equal to 0, and we actually break here. Otherwise, we just decrement the count. And the reason for this may seem a little confusing, but the reason is that you can have used all of your space characters, right? The characters that fill characters, but then there's something outside. Even though you don't have any more fill characters, you have to sort of finish the sequence. That's kind of what happened here. We had this. We used our fill character here for B, and then we wanted these other two B's. We didn't end up counting them. I think we ended up just doing AA. Oh, same thing for this other A. So I think that's a slight, very subtle thing there. Yeah, and obviously we had to use a fill character on I if we're not equal to the target. Yeah, necessarily. So, okay, I'm afraid to do more test cases, but let's do some stuff here. Let's just do some random things. Oh, 0 to 13, really? Wait, really? Oh. Oh, okay. I think I get it. All right, I think we got it. Let's just try like something simple. I don't know, man. Try one more thing. All right, let's go for it. Hey, you got there. Sweet. Okay. So there's probably a more efficient way to do this, but that's sort of good enough, I guess. How did we do? We had 25 minutes? Not great, but, you know, okay. I think most interviews, you probably get around 40 minutes to do something like this. I did make an error. That's a very subtle error, though. This is like super custom code, too. Like, this isn't very, It's like kind of unique to how I solved the problem, I guess. It's a sliding window, kind of like this sort of an off by one error type of thing that I missed here. So if I had submitted this code, it would have been wrong. That would have been unfortunate. I don't even know how I would have made sure that this is right without like running through some cases by hand. That's probably going to be the hardest thing for me if and when I interview with these kinds of questions. Yeah, not too bad. All right, let's try another one. All right, so what I'll do is I'll end the stream here and then start another one. So yeah, thank you for watching. Take care.